Hello everybody, this is Mr. Fishel, your teacher, and today our learning target is going to be learning target number 2. I can understand and use the midpoint and distance formulas on a coordinate plane. I can understand and use the midpoint and distance formulas on a coordinate plane. So we've got two things we're going to learn about today. So first of all, midpoint distance. Let's talk about distance. I like to talk about distance a lot. In order to talk about distance, I actually have MapQuest up here. And you probably recognize this area right here. Let's see, where are we at right now? Here's Southern, here's 5th Street, so we're right in this area right here, right along Southern Avenue. So you guys probably wonder, probably think it's pretty easy to calculate distance, right? So if I'm going along this street, let's say these blocks were all the same lengths, I could count blocks. From 8th Street to 6th Street right here. Looks like it's 1, 2, 3 blocks. All right, and then if I was to go from Southern down to Laketon, looks like it's 1, 2, 3, 4 blocks. So pretty easy counting up and down like that. But you see all these streets right here, like Houston, Muskegon, Webster, we've got some other streets right here. They're on an angle, so it's a little different. So I want to show you something now. I'm going to take a screen clipping of this area right here. I'm going to put it on Mimeo like this and expand it just a little bit so you can see. All right, you see streets just like this. Looks like Strong is one of those streets. Houston, Muskegon, they run on an angle. So it's a little more difficult to figure out how long they actually are. All right, so what people like to do this, it goes back to a mathematician, his name was Pythagoras. He used what's called the Pythagorean theorem. So what you might want to do is, if I want to figure out how long Strong is, for example, from here to here, I'm going to make myself a nice triangle. Okay? And Pythagoras said, if you have a right triangle, a right triangle is a triangle has a right angle right there. It's marked with a little box. Remember, like we learned in learning target number 1, that if we take the length of this side squared plus the length of this side squared equals the length of the hypotenuse. The right angle always points to the hypotenuse. The length of the hypotenuse squared. So it's a squared plus b squared equals c squared. So you're wondering, well, what are we going to do with that? All right, so, all right, I'm going to open up a new page here, and I have a nice grid right here like this. So I'm going to take a screen clipping of that. Okay, and, well, let's make ourselves a nice diagonal line here. So I'm going to make my diagonal line from here all the way to here. Now this is the point 2, 1. You go over, then up. So again, this is the point 2, 1. Let's write that out so you guys can see that okay. This is the point 2, comma, 1. And this point up here is the point, looks like we went over 6 and up 1, 2, I'm sorry, over 6 and up 1, 2, 3, 4, 5, 6, 7. So it's the point 6, 7. And we want to figure out how far that is from here to here. Okay? So what I can do is I can just make myself a triangle. Whoa, that's not good. Let's erase that. Let's make a little better triangle than that. Come on, Mr. Fishel, you can do better than that. Okay. So I'm going to go straight up like this, straight over like this. To make our triangles, we're going to count the number of spaces. So from here to here, I go up 1, 2, 3, 4, 5, 6 spaces, right? Hopefully that's what you guys got too. This is our right angle here. I always like to mark that with a little box. All right, then over here, you notice we go over 1, 2, 3, 4 spaces up here. All right. So you can see this is, if you weren't good at counting boxes, you could also look at the x and the y value. You can see the x value changes from 2 to 6. It's going up by 4. And the y value goes from 1 to 7, so it's going up by 6. So it goes up 6 over 4. So to solve for this hypotenuse, and the right angle always points to the hypotenuse, we take 6 squared plus 4 squared equals c squared. All right, now, I'm sure you guys can do squared. 6 squared means 6 times 6, so that's going to be what? Yeah, 36. All right, and 4 squared is 4 times 4, which is 16. I'm just going to bring down my c squared. See, now we're doing a little algebra. Algebra is the basis of geometry. So we add 36 and 16 together, and you get a total of 52 is equal to c squared. All right, now what you need to do is you need to take the square root of c squared to get c by itself, right? That means we must also take the square root of 52. The square root is a key that looks like this on your calculator. So you try it. What do you get when you take the square root of 52? Well, I do believe that 7 squared is 49. So it's going to be a little over 7. So I'll do this on my calculator, and I get about 7.2. So that means the length of this side up here is 7.2. And that's how you use the Pythagorean theorem to figure out the length of a side. All right? So any questions on that? Okay. Well, next we want to figure out, you notice that the learning target had 2 parts. Let's just go back to that learning target for a second. We want to understand how to use the midpoint distance formula. Well, we actually use the distance formula, actually a version of it as a Pythagorean theorem. But now we want to use the midpoint formula. So let's go try something else here. So let's make a new slide and another screen clipping here. Okay, let's say I have another diagonal line. I always start with these diagonal lines because if you can do it for a diagonal line, then you can do it for a horizontal or vertical line. So, all right, I'm going to make another diagonal line, and let's write down what the points are for this one. So the points for this point right here, coordinates for this point are -2, 2. And the coordinates for this point up here are 1, 2, 3, 1, 2, 3, 4, 5. So they're over 3 and up 5. All right, now midpoint formula is a little different than the distance because we don't want to find out how long it is. We want to find out where it is in the middle. And you're probably guessing, you're probably thinking it's somewhere right around in here. But how do we actually find out where that point is? Well, it's all based on averages. Can you think of how you figure out the average of 2 numbers? Yeah, that's right. You add them together and divide by 2, right? So that's what we do right here. We're going to take, this is the formula, x1 plus x2, and we're going to divide that by 2. All right, so you're taking the average of the x's. You do the same thing for the y's. y1 plus y2 over 2. That's going to give you the average of the x values. Let's say when we do it right here, if we take a -2, that's our first x value, plus 3, our second x value, and we divide it by 2. Let's do the same thing with y's. 2 plus 5 and divide it by 2. Well, you have to use order of operations. You add the numerator together and then divide by denominator. So if you take negative 2 plus 3, what's that going to be? You're correct if you said 1. So we have 1/2 is going to be our x value. And now we add the y's together. 2 plus 5 is 7. 7 divided by 2, which is 3 1/2, or 3.5. So that's our answer. This is our midpoint. All right, so let's see where that is. So if we go over half, it'd be right around in here, right? And then we're going to go up 3.5. So we'll go over half, up 1, 2, 3, 3.5. And this is our midpoint. Now, does that look like it's halfway between these two? I think it does. Now, if it doesn't look that way, then you might want to recheck your work, make sure, see if you made a mistake somewhere. So we've just gone over distance formula using Pythagorean theorem and midpoint formula. All right, so now I'd like you guys to try a couple on your own. Please do the formative assessment right after this video. Thanks.